Thank you so much for coming here tonight. Today, we want to talk about the most current point of contention in contact tracing, which is Bluetooth versus GPS. What works better?
Professor Ramesh Raskar will frame the discussion and then introduce two leaders from the SafePaths technology team, Towle and Sam Zimmermann, for a little bit more in-depth look at the open source development they are spearheading.
My name is Deepti Pava. I work in the communications team at SafePaths with a focus on external brand messaging.
My name is Brian Wilson. I work in the comms and legal teams at SafePaths.
You will now hear from Professor Ramesh Raskar, MIT Media Labs, who also leads the SafePaths initiative. Bluetooth or GPS, what works better for contact tracing? And how is COVID SafePaths able to solve this puzzle?
Thank you, Dipti, and thank you, Brian. So wonderful to be here.
And today's topic is Bluetooth or GPS. What is good for contact tracing? To build a privacy-aware contact tracing solution. Digital contact tracing is about notifying if you have crossed path with an infected person, send an alert that provides location of where the contact may have occurred, and use GPS or Bluetooth on the smartphone to compute the proximity. And it's privacy, consent, regulation, trade secrets, national security, and incentive that we care about when we talk about privacy. SafePaths is an app that you can download, and it logs your personal diary, a personal diary of location and GPS and Bluetooth trails, and it stays completely on your phone, and you can compare that with publicly released case data. In the next version, we also have, again, a personal diary, which means your location and Bluetooth trails never leave your phone to a server, but you can download more precise redacted trails of infection cases from Public Health Department. And very soon, we want to release solutions which will reduce the burden on health officials by using self-reporting, authentication, and computational methods. You can download the SafePaths mobile app on Apple App Store and Google Play Store. And we also have one of the largest open source communities on GitHub that's building source code for these apps, the algorithms behind them, the protocols behind them, and also source code for the other tool, which is Safe Places, aimed at being used by public health officials. So this Safe Places web tool is a JavaScript tool for public health officials who can dramatically improve the speed and accuracy when they interview a infected patient. So this can be used by manual contact tracing operators as now, or they can import new types of data streams and create redacted information that will eliminate personally identifiable information, anonymized, aggregate, and in the future also encrypt the trails.
On the left, we have apps. It could be a SafePath app or any app that has been developed with our framework, because our GitHub is open source. So you can download and create your own app with our open source toolkits for exposure notification. And very soon you'll also see things like personal guidance and symptom tracking, quarantine verification, and other types of verifications. And we'll be working with many partners, whether they use our app or other app. On the right side, we have the web tool where for public health, we are creating solutions for, of course, improving these interviews and conversations. But very soon they can also see the hotspots and predict the spread and even coordinate at-home population with integrated dashboards and provide certificates. And all of this is based on technology APIs, some of them which are coming from many partners for GPS and Bluetooth and Wi-Fi and others. I especially highlighted the Apple and Google ones, but also from our friends at MIT through the MIT PACT protocol. The key is how can we provide this comprehensive toolkit for public health as well as for restarting the economy that's privacy preserving, either by using computational algorithms or using software principles. So let's get to the core of the discussion today, which is the wonderful announcement from Google and Apple about the proximity API or exposure alert API, as it's called since yesterday. And the key idea behind this exposure alert is two people can exchange keys over the Bluetooth channel by whispering locally. If one of them is infected, afterwards, they can upload the keys to the Apple Google server, and the other person who is supposedly healthy can download these keys from the infected person and see if they match the keys that they heard over the Bluetooth channel. And there's some more details, but we won't get into that in this short presentation. But let's think about its benefits and challenges. The benefit is that Bluetooth indeed provides the best proximity indicator down to a few feet. It's great for privacy if the server where the keys are being held and the access to the apps is tightly controlled. And because Apple and Google are benevolent companies and we can trust them, it provides a pretty good implementation which will be available. The challenge, of course, is that despite the benevolence of Apple and Google, the Bluetooth signals can still be snooped. So the challenge is, first of all, we're dependent on Apple and Google being benevolent or MIT Pact becoming a standard. The second challenge with Bluetooth is that the adoption versus effectiveness is very skewed. So even if we have a 12% adoption, the number of encounters you would capture will be only 1.44%, because the square of 0.12, the 0.12 times 0.12 is just 0.0144. Another challenge with Bluetooth is that fomites, which means infections that spread through surfaces, cannot be captured, because you could be in a coffee shop and an infected person may have left a trail 10 minutes or even 1 hour before you sat on the same table. Problem with Bluetooth is that inclusivity is a challenge, because only the users who have a smartphone, who have turned on the Bluetooth and who have opted in and have downloaded a corresponding app are the only ones who will participate in the system. And if you don't have a smartphone, or if you don't have good quality Bluetooth, you don't get any benefits from it, even if you're infected. And of course, you have challenges with false positives and false negatives. Somebody could have left their phone behind at a wedding while they're dancing with everybody at that wedding, and that won't be captured of their interactions. There are hacks, as in any other system, where emitted Bluetooth signals can be snooped by a third-party app. If there's a third-party app that has hundreds of millions of downloads, they can listen in an individual's Bluetooth signal over a 15-minute period and accurately reconstruct their location trail. And because the keys cannot be in public domain, countries like France have been challenging that the innovation will be stifled, because only certain companies will have access to it, in this case, Apple and Google, but not others. And again, I expect Apple and Google to solve this problem very soon. But if some other third party starts holding the keys of the infected people, that can create a challenge for innovation in this space. GPS, on the other hand, has its own benefits and challenges. GPS probably has the best privacy one can imagine, because all the GPS values remain on the phone of a healthy person. And the healthy person only is downloading the data from public health authorities and never uploading anything. This is the best privacy one can imagine for a healthy person. It's available on most phones. It's easy to implement with battery issues, and the adoption scales linearly. So if 12% of a city is adopting it, clearly roughly 12% of the infection sites will be reported in tools that are being used by public health. It's also inclusive. If population does not use a smartphone or even a phone, these location trails, after redaction and after removing personally identifiable information, can just be published in a newspaper or shown on a 7 o'clock news in the evening and disseminated in many other ways. So even the users who do not have a phone or even a smartphone can benefit by realizing which are the hotspots where there were infected sites. If they were at 2 o'clock on a Tuesday at a Starbucks, and the 7 o'clock news informs that there was an infected person on Tuesday at 2 o'clock at Starbucks, everybody else will know about it, and they can figure out what their next plan of action should be. The challenge with GPS is its accuracy, the fact that the infected person will have to rely on public health individuals to redact the information, and the fact that the encryption that's required for GPS cannot be achieved with one server, but requires two servers. The benefit of the location and context is very high. So let me explain that in the next slide. So if you use a purely Bluetooth-based approach, then the challenge is that it will not provide context of the location and time. And this context is very critical because contact tracing is all about time and location and the ability of a public health officer to call the possibly exposed person. So if you provide this information, a binary bit, you're exposed or not, it can lead to a lot of problems. A user may have a very low trust in the system because they don't know how to deal with false positives and false negatives. If they were at a wedding and they were not wearing a mask, they would like to know if the encounter happened at the wedding. On the other hand, if they were in a grocery store where they're wearing a mask and keeping social distance, that alert will mean nothing. And that would reduce the trust in the system. Also, a lack of agency and confusion of where exactly an exposed person may have been exposed can lead to irrational behavior. On one hand, they could panic. On the other hand, it could lead to risky behavior because they won't have trust in the system. Public health, on the other hand, needs to interview this person and understand the heat map and the spread analysis. So even if they call this person and they possibly exposed person, they cannot tell you if the alert is because they went to a grocery store or they went to a wedding. There's very little the public health entities can do because they'll have to quarantine a whole bunch of people at the grocery store and also at the wedding. And maybe the issue that's most problematic is without context, people who are exposed might start blaming people they like to blame, often minorities. Or law enforcement can become overzealous and start making their own assumptions of where these exposures may be happening, again targeting underserved population. And so if there becomes this battle and we pit neighbors against neighbors and communities against communities, that can lead to civil unrest. And unfortunately, we have seen that in many parts of the world where the fear of the virus has created a lot of civic issues. And finally, it's important to remember that there is proximity API, there's contact tracing, and what the public health really needs. What public health really needs to solve is quarantine verification, health verification, and immunity passport. So all these problems cannot be solved if the only information we're able to provide through Bluetooth is you're exposed. Not where, not when, not in what context. So the answer to this, and this is the approach that SafePaths is picking, is a combination of Bluetooth and GPS. Why not have the best of both? Bluetooth has, as I said, one of the best ways to detect proximity. GPS has the best mechanism to provide context. And the combination of the two can provide the solutions that we really care about. One could also imagine a solution where Bluetooth is used for proximity and GPS is used for context, and GPS is not used for proximity. Or you could switch to a fallback plan where if Bluetooth is switched off on a phone, is unreliable, or the user has opted out, or there's a concern of surface exposure like tables and surfaces, then we can use GPS as a backup. In any case, the combination of the two can provide great privacy because GPS log and locations can stay completely on the user phone. They never leave the phone anyway. Users can geofence, for example, saying, hey, I live here, so don't record Bluetooth or GPS coordinates while I'm in this geofence region. And the infected users can use the on-phone prompts to remember the sites. Even if they are not able to provide information because the Bluetooth was off or they had opted out. And of course, the benefit of this context, location and time and surroundings will eliminate the false positives, and interviews by health officials will also capture the false negatives. So if you're a government or public health or a big business that's deciding what solution should you use, here are a few criteria that we recommend. And we have a beautiful paper on the COVID SafePaths website that goes into a great detail on comparison of all the existing apps, existing solutions, and what factors are important. Again, we are here to collaborate, not compete. Whether you use the SafePaths app or not is not as important as that you are working in this interoperable framework. So here are the key factors we think are important for a population to start accepting it and for public health to endorse it. It should be privacy first. It should be open source, so you don't get locked into a vendor that has other closed source solutions. It's interoperable with other apps and the backbone that SafePaths is providing. It provides support in multiple languages. It also has a solution that provides value to non-smartphone users or smartphone users that is not using this app. The problem I mentioned about 12% leading to only 1.44 encounter capture. So you want to avoid those problems. So it should be possible to use newspapers and TV channels in coordination with such solutions to disseminate that information. There should be an ecosystem for public health that integrates with dashboards for hotspots and spread analysis. And it should be modular. It should not be something that displaces existing health IT, but it's modular and it integrates very beautifully with the existing health IT solutions. So we're very proud of the SafePaths Alliance, our team at MIT and faculty members who are co-leading it. Our work is shaped by great mentors from WHO and CDC and HHS and Mayo Clinic. And also it's wonderful to have partners who are experts in privacy and machine learning and security and epidemiology and societal issues. And of course, our major partner here is PathCheck, which is a nonprofit that's working on rolling out many of this, a lot of this work in over 40 different health jurisdictions now in partnerships with EY. So as a reminder, SafePaths is not about the app. It's about an ecosystem that has a technology layer, the app, the Safe Places web tool for health authorities, the open source code, APIs, algorithms. You'll see more and more algorithms on our webpage coming up. Interoperable backbone, privacy guidelines, landscape analysis. The paper is out this weekend. You should check it out. Public health engagements. And we're also working very closely with many corporates and startups who want to use the SafePaths open source platform to provide a solution. If you're open leisure technology or identity solution, or you have an internet connected thermometer, you're providing serology tests, or you have new types of incentive models, you can provide immunity passports through your existing software platform. Many of these organizations are already working with us on how they can be plugged into the SafePaths architecture. And also we're working with many corporate entities who want to use solutions from this solutions provider. So solution seekers and solution providers are also working on the SafePaths platform. And you're welcome to join this coalition. So to conclude, it's obvious that to overcome this challenge, governments and businesses have to choreograph the solution. At the same time, it cannot be a top-down privacy invading solution. We have to let the communities and individuals coordinate amongst themselves using privacy preserving tools. And that's what SafePaths is all about. Creating a solution in the short run for the epidemic and for public health, in medium term for restarting an economy that will be more glorious than before, and building resilient societies. Thank you.
Thanks so much, Ramesh. As you can probably guess, based on how quickly this whole project has come together, how many partners there are, and how big this ecosystem is quickly growing to be, we have a really large team of amazing people working on this from all around the world. With the next segment, we wanted to bring forward some of our most active contributors whose job it is to be able to speak directly about the Bluetooth GPS implementation of the SafePaths app. So let's bring in some of those leaders from the tech team, Sam Zimmermann and Kyle Towle. Sam and Kyle, great to have you on today. Could you please quickly introduce yourselves and speak a little bit about how you got connected with SafePaths?
Happily, yeah. My name is Sam Zimmermann. I'm heading up technology here at PathCheck, and it's my responsibility to kind of harness the amazing movement that has been created through volunteers in our open source community to build the technology conditioned upon the principles that we've set forth. Prior to this, I was an entrepreneur, most recently at a General Catalyst-backed startup I co-founded, and prior to that, worked in consumer tech, finance, and machine learning.
Thanks, Sam. Kyle Towle here, working with Sam here, leading the web tool development for Safe Places. A little bit background on me. I had a 14-year career at PayPal. So I retired actually from that last year, and was looking for opportunities to help out from a volunteer standpoint with exactly this technology challenge for combating this COVID-19 pandemic. And that's how I found Sam and found the wonderful group here and able to contribute. Really awesome to be here with an amazing group of folks.
That's great to hear. And I think it's a testament to the transition that's kind of going underway, and some of the tensions that have surfaced as we move from a paper-based operating system to one that's more digital. And so with that, I'd like to get into a few of the questions. So Jeff and Manuel ask, is this app that I have on my phone called PrivateKit the same as COVID SafePaths? And where are we in the process of getting some of these things published in the various app stores out there?
So PrivateKit is an MIT research tool that will continue to exist. But as we transition to a full-fledged health app, PathCheck, which is a nonprofit that works with SafePaths, will release new apps. The first app is, of course, COVID SafePaths, that you'll have it available in iOS and Android app stores. So you'll see a transition from the MIT app, which is more of a research app, to full-fledged apps and a series of apps under the SafePaths branding.
We have another question from Avinash, which is how authorities collect and update patients' tracking data. Will the web tool open to public too, or is it open to public too, or is it just for health officials?
So the web tool itself is open source. You can go to our GitHub page. I should mention that we have a very, very active GitHub page. If somebody can post a link in the chat page, and then we have hundreds of contributors that are either contributing to the existing GitHub page, or creating a fork, or creating an issues, or merging them. So you can continue to contribute. In addition, we have GitHub for Safe Places, which is a web tool for public health. So anybody can use it, but of course we expect, a version that's used by public health they will keep the data themselves and keep it encrypted and keep it secure. So although you have access to the source code, individuals will not have access to that raw data.
So the efficacy of these apps rely on users following best behaviors to report the precise location and not hide essential trails. So for example, leaving phones at home when they go out, or accidentally turning off. And so Sharice asks, is there work on the feature that ensures users are reminded of some of this stuff so that they know that they're following all the best practices with SafePaths?
So the best case scenario is that everybody has their phones on, everybody has a smartphone, everybody has turned on their GPS logging and Bluetooth protocol and so on. But in reality, epidemics is a game of probabilities. And as long as a significant portion of the people are using these features, we can bring the R0 below 1. The challenge with Bluetooth is that, as I said, the number of encounters are the square of the number of users. So it does have challenge, especially if you cannot provide context of location and time. The benefit of including GPS is that even if the infected person forgets their phone at home, and even if the exposed person forgets their phone at home, through interviews, public health officials can release a map of, hey, 2 p.m. on Tuesday at Starbucks, or 4 p.m. at the grocery store on Wednesday is where an infected person was. And then you can disseminate that information to others. Of course, if you already have the smartphone app on the healthy person's, if the healthy person has a smartphone app, they will get that exposure alert automatically. So the beauty of adding the context is that it uses the human intelligence, and it's not dependent on technology for everything to work right.
So there's a very interesting question here from, he says, the EU Data Protection Board technical guidance says that location history should not be used for contact tracing. Putting the technical argument aside, is there engagement underway with European Commission or DPB?
Yeah, we have many conversations going on with many entities that really care about privacy and ethics and security. And actually, the EU data protection guidelines are that the GPS locations should not be shared to a central authority. And SafePaths obviously, is one of the most private, which is the location history of the healthy person always stays locally on the healthy person's phone and never gets shared. So it's consistent with that as well.
Because we have some of the great leaders of the tech team in this, I want to ask a little bit more technical question. So a lot of people are wondering, Vida specifically asked, can we elaborate on some of the AI algorithms that are being used and how they preserve privacy with diagnostic data?
I would group the set of techniques we're using into three categories. The first would be differential privacy, which is a way of building machine learning models that respect privacy by ensuring certain constraints about how models are built are contained occasionally via adding noise or reducing information to a certain geography. The second major way that methods we're using involve encryption algorithms. These are both kind of standard ones you see used with enterprises and big banks today, as well as some cutting edge research coming out of our algorithms and privacy team. The third domain, which I think it ties into the conversation we're having today, is AI and ML to integrate these different protocols in intelligent ways that preserve privacy while enabling us to intelligently provide information to health authorities, epidemiologists, and individuals who are infected.
So what is the relationship of the team to Google and Apple and the Lincoln Lab teams? Do you believe that Apple and Google will adopt GPS or Bluetooth hybrid approach?
Yeah, let me take that question, and others are welcome to add. So this is a wonderful question. This is the main topic of this conversation. So Apple Google API is an exposure alert API. You can think of it as a proximity API between two phones. And although it doesn't provide the context of the location or the time, because the only information an exposed person would know is that they were exposed on Tuesday, but they won't know on Tuesday at what location and at what time. And the expectation of Apple and Google is that public health entities will create their own apps to decide how that information should be disseminated, how to preserve privacy, and more importantly, how does this play with the role of contact tracing? As you know, Apple, Google initially called it contact tracing. They don't call it contact tracing anymore. Now they call it exposure alert because contact tracing actually involves public health individuals calling the exposed person and trying to understand the context of what happened, where they were, what were they doing, were they wearing a mask, were they maintaining a social distance, what health condition do they have, what situation do they have at home, can they even self-quarantine, or do they have challenge in maintaining a quarantine, and so on. So the expectation from Apple and Google's in a public documentation is that these other solutions will provide all those solutions. And our friends here, MIT PACT, will influence some of these Bluetooth protocols. And then SafePaths is creating an overall framework that will do not only exposure alert, but providing context and providing all these solutions downstream. So you can think of Apple Google API as the technology and servers. You can think of MIT PACT as the most solid way to propose a protocol, and SafePaths as an overarching ecosystem that has the app, the public health, the algorithms, the landscape analysis, and rollouts and partnerships with many startups and corporates to put those pieces together.
A lot of people are concerned about some of the potential privacy issues with using some of these apps on their phone, especially when Bluetooth can be casting your location for quite a while. So Heather and Jim both have asked, how can I ensure personal security when using the app? In other words, how how do we make sure that this approach is kind of the pinnacle of what's out there and more secure than other apps?
For a healthy person, recording their GPS location locally is the most private way you can imagine building a system. The next best, but maybe not as good as just recording GPS locally, is to use Bluetooth, where some information is being leaked from an individual's phone constantly at roughly every 200 to 270 milliseconds, roughly 4 times a second. They're sending out a chirp, they're sending out a signal from their phone on a Bluetooth channel. Although it's randomized, attacks are still possible. Nevertheless, it's still a very good system, especially if we have good companies like Google and Apple providing as much protection as they can provide. So for a healthy person, maybe the best case scenario is GPS only, but it has limitations in accuracy of proximity. The next best solution is slightly lower privacy with respect to by using a solution with Bluetooth, although it has a better abilities for proximity. For the infected person, the privacy with Bluetooth is unfortunately challenging because they have to upload it to the server, and others can download this almost public data set. And with GPS, we are relying on public health individuals to release their redacted trails, which means they also have a challenge because we have to make sure that the public health professionals are trained well enough to make sure they don't accidentally leak any personally identifiable information. And that's why we are partnering with partners like Ernst & Young, who are providing this training in many jurisdictions as well. So I think on one hand, the 3 types of privacy. There's a privacy for the healthy person, the privacy for the infected person, and the privacy for the business. And in our opinion, GPS has the best privacy for healthy individual, slightly less with Bluetooth. For infected person, in both scenarios, some privacy is leaked. And for businesses, there's a lot of privacy is being leaked.
The framework Ramesh outlined actually is instantiated in our code via different products. The SafePaths app, our API and SDK, and kind of the Safe Places web application used by health authorities, managing both kind of the COVID positive individuals and addressing health authority concerns. Kyle runs point on these Safe Places project, learns from the implementation and global rollout team about what health authorities want, and can speak a bit to the challenges and learning of balancing those 3 priorities in the Safe Places project.
One of the exciting things about this role has been, all of the, contact and communication with health authorities who are trying to combat this pandemic. And what gets me excited is when, they look at the products that we're looking at and look at it and say, these are must-have solutions for opening up our state or opening up our city again. And particularly the doctors and epidemiologists that we talk to are really excited about the Safe Places tool and the ability to use this sort of GPS location trail as an aid to contact tracing. I mean, it's going to be game changing for a lot of folks on the ground in these clinics going through this exercise. And we're trying to balance that efficacy side of being really effective for the public health side and the privacy of citizens. And so that's something I think we've with the approach we've got between the app and the web tool, and the way that we train contact tracers to redact or remove all of the sensitive personal GPS trail locations from the data that's stored by public health officials, and the fact that there is no central place where this is all stored. It's going to systems that already store sensitive information about patients. That's far more sensitive than maybe GPS trail locations of public areas they've visited. So I think really excited about the privacy protecting side of the solution and how effective this is going to be for combating COVID-19, even before we integrate Bluetooth for more accurate proximity side of the house. It's really exciting.
Great, Sam and Kyle. It's really nice to hear from you as well. I mean, it's really making the conversation more multidimensional to hear the thoughts of the team as well who's working on it. What do you think about centralized and decentralized debate on the app backbone? And if SafePaths is nearer to PEPPT, the European, pan-European network, as well as DP3T model?
Yeah, that's a great question. And if you saw our slides, I think the GPS approach is actually naturally decentralized because the infected individuals load it to the server, and then all the healthy individuals download it on their own phone, and all the calculations are done on the phone. Just for those of you who are not familiar with the terminology, centralized means all the encounter calculations are done on the server, and decentralized means those encounter calculations are done on the phones of the healthy people. So we do believe in the decentralized approach. At the same time, as Sam mentioned earlier, we have some really clever algorithms that allow us to provide solutions to health officials in a centralized manner. So the encounter calculations all take place in the decentralized way. And I know there's a big debate going on between the PPPT team and the D3PT team. We have friends on both sides, and we need to understand their decisions better. But SafePaths is promoting the decentralized approach.
How can we ensure long-term interoperability between these apps that are coming up around the world, and what mechanisms do you think people should adopt, and how might you counsel even other groups that are developing for this ecosystem as the best kind of ways to plug in?
This is actually the most important question. I'm so glad somebody is thinking about it. We have said from day one that we are not here to build an app. We are here to create privacy-preserving toolkit that cuts across all these problems. And so we're very delighted. Many organizations, so we have a very active GitHub, and we are helping many organizations to build their own apps. And whether they reference back to us or they go in a different path, it's completely up to them. If they reference back to us, we are providing a lot of help in new algorithms, new protocols connected to the backbone. And so we expect nearly every country to have their own app, absolutely. It's not going to be one global app, or not even one global app in the US. And what's important is that they all talk to each other, they follow privacy principles, they're interoperable, and it's very easy for us to talk to each other. And through this ecosystem that we're building at SafePaths, we're really creating an umbrella, so a lot of these apps can be based on our GitHub code.
On the technical side of things, we're kind of a downstream consumer, I like to think, of the think tank work and the immense coordination going on in thinking deeply with experts from around the world about what sorts of protocols make sense. We take that information and the principles around preserving privacy and maintaining efficacy and instantiate them in very clear, simple interfaces in our open source code. Those interfaces enable third-party applications to understand the contracts involved in interacting with our tools and provide examples to replicate on a country-by-country, nation-by-nation, or institution-by-institution manner. And so we kind of are downstream consumers and are responsible for making it as simple as possible to maintain these interoperability standards.
I'm particularly excited about this aspect as well, and I think the key is just the way that folks are leaning in to engage on this, and I think that's one of the things I've noticed from PathCheck and this group that we have assembled, tackling this problem is it's incredibly collaborative and engaging with many of these groups outside, and so that would be the message to folks who are really interested is lean in with us. Together we can tackle this pandemic and the software and the technology and the ecosystem we're trying to build to equip public health officials, equip citizens and businesses to be successful.
Yeah. So if you're in any country or any jurisdiction, we want you to build your own solutions. We are not about the app. Even if you want to create one in Massachusetts, we will help you create an app for Massachusetts, because our focus is not just building a consumer-facing solution. Our focus is to create, those that think tank, that software, that open source toolkits, and especially abilities for other solution providers and solution seekers to connect in our system. Also want to introduce Greg Nadu, who leads PathCheck.
Hey everyone. I think the one thing I just wanted to add is that the work we are doing will be expressed through international standards bodies. We're working with IEEE and expect to continue working with W3C and ISO in order to express the privacy principles that have been published by the computational law site at MIT. to be a set of protocols that can then be followed with data interoperability standards.
Thanks so much, Greg. And thanks. I just wanted to thank all the panelists for joining us today and for providing such a robust discussion about how these different apps are really helping to build and populate this ecosystem. It truly, I think, does take a village. So there was a question from Alessandra who is asking which states, countries, or other jurisdictions have already, adopted SafePaths, and can we get a little bit more insight about who's interested and what some of the immediate next steps might be?
Yeah, let me take the first part of it and I'll hand it over to Greg. So we're delighted that we have discussions going on in over 40 jurisdictions, and we have to let them announce any partnerships. We are not allowed to announce those partnerships. But more importantly, the key here is that we are working with other providers, whether it's you're a health IT provider, or you're a consulting company, or you have a solution that's already going on. I should also clarify that we are huge supporters of the manual contact tracing framework that's being built in many US states and worldwide. We are huge supporters that a piece of software is not going to solve this epidemic. We still need talented public health individuals who are playing that role. So we want to work alongside them and not come up with a techno-optimistic solution that somehow is going to solve this problem purely with technology. So in that sense, we are working alongside big software companies, alongside big consulting companies, alongside health IT companies to provide a solution that's privacy preserving, has the great algorithms, connects to the backbone, has the think tank supporting them, and also bringing in other startups and innovators to plug into that play. So I'll hand it over to Greg.
Yeah, so I think that might be a good topic for us next week to focus on, is bringing in some of the initial jurisdictions, talking about the initial pilot experiences. And we're an idea that became a project that's becoming a community and a global movement. And so what's starting to happen is that we're shifting from a primary focus on technology to now a primary focus on the community and the support for all the sites that have asked for our help. So you'll see a lot more from us soon about that. We'll be changing the way that we interact with I think it's 37 actual jurisdictions inside the US and now 47 or something international. So we're working together with those groups, and they go through a process of sending us a letter of intent and then signing a memorandum of understanding and then beginning to pilot. And at that point, then we can make more public what we're doing with them.
Thank you so much, Greg, Ramesh, Kyle, and Sam. I think that was a great discussion here. And we would like to thank all of you for tuning in today, as well as my wonderful co-host, Ryan. I hope we connected well with you all and you're staying safe, calm, cautious, curious, but most of all, connected.